some of the basic kinds of calculations which we may have to do using the normal distribution, keeping in mind the various applications that normal distribution engages into. My name is Vamsidhar. I'm the founder of PACE, which is a training institute primarily into finance and analytics trainings using tools like Excel and SPSS. For further details about the various training programs which we offer, you can log on to our website www.pacegurus.com. Now, let's get forward and try to understand what this normal distribution is all about. Just a quick recap. If we understand the word distribution, then we can think what a normal distribution is all about. In statistics as well as probability world, when we talk about distribution, it's nothing but all the observations of the data which we have taken into our sample. All those observations, if I classify them into some class intervals and try to plot a graph of the class intervals and the frequencies, that is what we call as a distribution. Any graph that is first grouping all the data into relevant class intervals and plotting a chart between the class intervals and the frequencies is what we call as a distribution. Now, these distributions could be discrete in nature or continuous. If the number of outcomes possible are finite, I call it a discrete distribution. If the number of outcomes possible are infinite, we call them as continuous distributions. So, depending on the shape of the graph that we get, when we plot the class intervals on the x-axis and the frequencies on the y-axis, the names have been given to those distributions. And one such distribution is what we are going to deal with today, which is a normal distribution. As the name itself is suggesting, it's a normal. It's one of those distributions which is observed quite normally, quite commonly in various applications of our data. For example, if I take the heights of some 100 Indian males, what we observe is when I try to group that 1000 data into a class intervals and try to identify their frequencies and try to plot a graph, it looks more or less similar to a normal distribution. Similarly, a profits earned by a trader in a stock market, that also follows a normal distribution. And there are so many such applications. Why do you think most of our real world data follows a normal distribution? There is a reason behind it. We'll get into it. Just to explain you the concept much better, I have taken one data. Observe this data. This is the profits that are generated by a trader in a particular stock market transaction over the last 250 days. You see, we have 250 observations. Close to 251, and the first one being a heading, we have 250 observations. So probably what I can say is on one day he has got around 1.78% profit. On some other day he got 0.85% profit. And similarly, he has got minus 0.4% profit, which is a 0.4% loss. So like that I can typically look at this. Now, what are we trying to do? First of all, why are we trying to understand these distributions or these shapes? The prime intention is the moment I know the pattern of the data, the distribution is nothing but the pattern of the data. The moment I know the pattern of the data, I should be able to make predictions and estimations quite comfortably. That's the prime intention behind doing any kind of statistical analysis. So I'm trying to find out what is the pattern of this data. So when I have looked at some of the important things specific to this data, I tried to find out the average of it. Yes, the average is 0.53, which is nothing but the sum of these numbers divided by the total number of numbers. So the average of this is 0.53. The standard deviation, which you should be quite comfortable by the time you come to normal distribution, has come out to 0.78. And a couple of more things about this data. The minimum value inside this list is minus 1.39%, which means the trader has lost 1.39% in a day. And maximum value is 2.74%, which means he must have gained 2.74% in a particular day. So using this, I wanted to see what is the kind of pattern that is present in this data. For that, I have divided this entire data into intervals. Because the minimum value is minus 1.39, try doing something like minus 1.59 to 1.39, minus 1.39 to minus 1.19, something like this, where each class is having a size of 0.2%. Every of them, if you see, minus 1.19% to minus 0.99%, which is like a 0.2% is the size of the interval. Now, I have tried finding out what is the frequency of each of these, which means how many values are lying within this range. So minus 0.99% to minus 0.79%, we have 7 such occurrences, which means on 7 days, this person has got a return in between those two numbers. Similarly, between 0.4% to 0.6%, there are 27 days on which he has got that kind of a return. So this is the frequency. I want to plot a graph between the interval and the frequency. If I am trying to plot a graph between the interval and the frequency,